Hi, this is Ida, and welcome to Episode 2 of the walkthrough of the HackerRank C language track. In this episode, we'll be going through the Basic Data Types challenge. Right there. If you haven't viewed Episode 1, go do that now. I'll walk you through this challenge and point out tips, pieces of C++ information, common errors you might encounter. Remember to do your own work even though I'm going to solve the challenge for you. I'll show what my process is, but you really need to do this yourself to get value out of the challenge. Please note that the website and all content from HackerRank is their copyright material, which I'm using for educational fair use purposes. Let's get started. As mentioned in Episode 1, when C++ takes a value, or passes a value, or remembers a value, it needs to know what kind of value it is. That kind is referred to as a data type. Here are 5 common data types, and they're kind of in 3 different groups. The first 2, int and long, store positive and negative whole numbers, or integers. Int stores numbers plus or minus about 2 billion. Long stores numbers about plus or minus 8 quintillion. Char stores a single character, an alphanumeric character, just one, ABC, 1, 2, 3, whatever. Float and double are 2 versions of a way of storing numbers that have both whole and fractional parts, and they do so to different precision. Float is accurate to about 1 part in 10 million, where double is accurate roughly to 1 part in 10 quadrillion. This is useful if you're doing scientific computation or even video games. And so I note this here, though we won't run into that in this challenge. Additionally, we're going to be looking at a new way of getting data in and putting data out, Scanf and printf. These are the ways that the C programming language have input and output values. Scanf and printf both read and Scanf reads and printf writes to standard input and standard output, respectively, and they function in the same general way. They have the name of the function, scanf, a format specifier, and then a list of variables that will be read to or written from. So the format specifiers denote what kind of data scanf should be looking for or what kind of data printf will be outputting. Up here in this list, they've put the format specifier. Each format specifier starts with a % and then has a little mnemonic string after it. For example, integer is %d for digits, long %ld for long digits, character C for character, F for float, double long float, LF. So those are kind of good to remember. The other thing to note here is this ampersand. Ampersand is a way of finding out where a variable is in memory. Because we're going to say, hey scanf, take this variable we're going to send you and write what you get from the input into it, which means scanf needs to know where to write. So the address operator, the address of operator, this ampersand, finds where in memory a variable is, and scanf will then write the result of its input to where that variable lives in memory. As you can see in this example, we have 2 variables, one of type character, one of type double. We have a format specifier denoting that the first field to expect is a character, the next one a double, separated by a space, and then we give the address of the character variable and the address of the double variable. And scanf will then write the results into the variables that live at that address. Printing is very similar. The format specifier from that list above is used to describe how to output. What kind of value is being sent to it is specified in the format specifier. And here, note that we don't have an ampersand as we had above because the printing doesn't need to know where the value lives. It just needs to know the value. So to output those same two characters, those same two variables, we have the same format specifier, and we just give the names of the variables and not their addresses. So let's go on to what this challenge is. We will be inputting one line with 5 values of the following specific types. Here's a sample input, and then we're outputting those same values in the same order, but instead of separated by a space, we're going to separate them by a new line. All right. This seems like good information that someone reading your program might want to know, so we're going to put it right in the program. And the way we're going to do that is using comments. We used but did not describe in episode 1 the // comment. In C++, any line that has 2 slashes, everything after that, those 2 slashes, is ignored by the compiler. It can say anything, it doesn't have to be valid C++. So we're going to write some documentation. So we're going to say, this program reformats data. And then we're going to give the same information that we were given, what the sample input looks like, what the sample output looks like, and it's all in comments, so C++ will safely ignore it. But it's also right here, so we can refer to it. Another piece of information that will be useful, and in real world you'd probably just keep it open in another web page, but we'll just copy it down so we have it with us, is these format specifiers. Let's put them down here. I'm going to fix the capitalization because these data types are in fact not capitalized in C++. Case is important, is significant, so that if you were to attempt to give a type by the name of int with a capital I without defining it, you would get an error. So now we have some documentation about what we're trying to do. We have a little reference documentation of what we'll need. And again, in the real world, you would want this kind of documentation that I've got here, and you wouldn't want this unless this was some kind of information that generally wasn't available, say, in any book on C++. All right, well, what do we need to do? Well, like the input-output challenge, we need some place to store these values. And the order is an int for the first field, and we'll just call it first. A long for the second field, which we'll call second. A character for the third field, which we'll call third. A float for the fourth field, which shockingly we'll call fourth. And a double, which we could call whiskey, but I'll just call it fifth, which you could also call whiskey for that matter. So we now have places to store all the values. Well, if you'll remember from above, we get those values from standard input using Scanf, and we have to tell it what to expect. Well, we say that again in a format specifier, which is a string, which is characters enclosed in double quotes. And what is it that we have? We have an int followed by a space. We have a long int followed by a space. We have a character followed by a space. We have a float followed by a space. And we have a long float. And we don't have any information of what follows next. Okay, we know what Scanf should expect to see. And now we have to tell it where to put it. And that's going to be these variables. I hope some of you are yelling at the screen going, wait, you forgot something. And you're right, I did. Scanf needs to know where these variables live in memory, so we need to take their address and say, here, first lives at this address, second lives at this address, third, and so on. Okay, what's the next part of this task? The next part of this task is to output it. Well, since it's the same fields in the same order, we'll duplicate this, avoid some extra typing. Instead of scanf, we're going to printf. And you're going to note that we don't want to output with spaces in between. We want new lines, and that's denoted by \n. It's a carriage return. The backslash says, hey, I want to describe to you a special character, for example, \t for tab. And there are a few others of note that are in the C++ documentation, and we don't want a tab there. We want a new line. So what is our output format specifier? An integer, carriage return, a long integer, carriage return, a character, carriage return, a float, carriage return, and a double carriage return. Oh, wait. Printf only needs to know the values, not the addresses of the variables. So it just needs to know the values from the variables. So let's get rid of that address of operator. And here we are. We're going to read it in. We're going to write it out. Looks like we're in the right order. We've got addresses of the things to send to scanf, and we've got values for things we're sending to printf. Let's run it, see what happens. We have a success. Good. So, what could have gone wrong? Well, we've got the usual, I forgot a semicolon, and that would come up as an error. But let's say that I got confused and I thought instead of a character, I wanted to have a digit here. Well, what would happen? Well, there's a couple of things to note here in the output. C++ has useful warnings. It'll tell you, hey, I see something, it's not an error, but maybe you might want to think about this. It says that the fourth argument here, 1, 2, 3, 4, 1, 2, 3, 4, is a type of, it has the type of the address of a character. That's what character star means. But the third format specifier here is something that expects to see the address of an integer. Well, things are probably going to go wrong. And they certainly did. Look at our output. Not only do we not have a as a character, we also don't have valid values for these other two. Well, what happened to them? Well, when scanf finds something it doesn't expect, for example, it found the letter A when it was expecting to see a digit, it simply stops. And we can show this by giving initial values and seeing if these values change. A character is represented by a single quote and then a single character within that single quote. Before we finish solving the first problem, let's create another one. Imagine I forgot the scanf. When I run this and I look at my output, I can say, hey, it doesn't look like I read anything. And you're right, we commented it out. We didn't read anything. So it's useful to have recognizable default values. So let's go back and get back to the other problem we had created, the mismatch in format. Again, we get the same warning that this guy is of type character star, but it expected to see something of type integer star, star meaning address of. And you'll notice that the first two values have been set correctly, but everything after that has the value it had before. Scanf just quit. All right, so that's the symptom of I've got an incompatible format descriptor for what I'm trying to read. All right, what else could we do wrong? Well, let's imagine that we were to put these in the wrong order. If we'd given them worse names, it might be easier to imagine that we'd put them in the wrong order, but we'll reverse third and fifth. Now we're going to say, expect to read a character, but store it where we would store a double. And worse, because characters are smaller than doubles, expect to read a double and store it at the address where a character lives. Well, a series of additional warnings come out. It's very upset that it expected to see character star, but it got a double star and vice versa. And when we look at the output, everything is garbage. Not only did one value never get written, or maybe it did get written and it just happened to be 5, the other values have been corrupted. That's because we handed an address that was too small for the value we were going to write. So, and what's interesting is not everything's corrupted. The second value isn't corrupted. The first one is. The third one is garbage. The fourth one, surprisingly, is garbage. And the fifth one isn't changed at all. So this is a serious problem. It's really, really gobbledygook, but the warning helps us with it. And we can see that the side effects are a little strange. It's important to, when you see these kinds of side effects, to look at your values, having good default values, and then looking at the line that was manipulating those values. Let's go fix this. And I'll give you one more potential problem that you can see sometime with Scanf. What if I forgot to take the address of first? What I've told it is that first lives, it thinks what I'm giving it is a memory address. And what memory address I'm giving it is the value that's in first, which is 1. Well, not every memory address is writable. When the operating system runs your program, it sets up some memory that you have permission to write, and some memory you don't have permission to write. And what does that look like? It looks like a segmentation fault. That says you wrote to a place in memory that you didn't have permission. Again, we have a nice warning here that points us to what we did wrong. It expected to see the address of an integer, but it got an integer instead. That's bad. And then one more piece of information is what's called a stack trace. It shows you in reverse order where the code was going when it blew up. We started in main and we called scanf. Well, that tells us actually the line that the problem started at in main, at line 20. Well, that's as we expected. Scanf is the problem. And we can see that we got into Scanf, a little further down into Scanf, a little further down into Scanf. And these are different function calls that the system has. And eventually we tried reading or writing to the address 1. And the operating system said, no, you don't get to do that. So there's a couple of good hints to help you sort that out. And let's go ahead and fix that. And let's make sure that we have fixed it. We have. And let's run all the test cases. Yep, we did them all correct. Well, I've shown you how to walk through. I've shown you with a walkthrough how to solve this. I've shown you a few things that can go wrong, and given you a couple of tips about what kind of comments you might want to put in a program going forward. I hope you enjoyed this, and you'll come back for episode 3. See ya.